Okay, I'm going to do a short video on understanding compound angles, cofunctions, and reduction formulae. Just basically what I want to do is to help you become more comfortable with the unit circle. Basically, if I have the sine of theta, let's say, the sine of theta, what will happen if I want the sine of, let's say 90 plus theta, or even the sine of let's say 90 minus theta? How do you think about that? How do you work that out on the fly? So that's what we're going to do. Stick around. I want to show you something that'll make this all a lot more comfortable. So we're going to start with our unit, not our unit circle, our cos diagram. And for this demonstration, it's very common. It's very common to see someone using kind of an arbitrary x, y, and an arbitrary theta. I'm not going to do that for very specific reasons, and I hope it becomes clear over time. What I'm actually going to do here is I'm going to create a 30, 60, 90, obviously, triangle here. And so this will be 2. This is a very common triangle. You should actually memorize this triangle. This will be 2. That's going to be 1, side opposite the 30, and this side opposite the 60 is going to be, I'm going to write this very small. You might get annoyed with me right now, but there's a reason I'm doing this. This is going to be root 3. Okay, so real quick, what's our sine? Our sine of 30. What's our cos of 30? And what is our tan of 30? What's our sine of 30, cos of 30, and tan of 30? And you will remember your SOHCAHTOA. SOHCAHTOA. First thing you learn in trigonometry. SOHCAHTOA. Well, what's the sine of 30? That's opposite over hypotenuse, right? So that's 1 over 2. What is the cos? Well, that's adjacent over hypotenuse, root 3 over 2. And tan is opposite over adjacent, 1 over root 3. Okay, easy enough. So now, what will actually happen? What will actually happen if I wanted the sine of 90 plus theta? Basically, for this demonstration, 90 plus 30. And I wanted to know, what is the cos of 90 plus 30? How do these relate? And what is the tan of 90 plus 30? How would we think about that? First thing we have to realize is that, let me draw it for you incorrectly. Let me draw it incorrectly, and this is a very common mistake. This is the incorrect drawing. That's incorrect. Why? Why is that incorrect? If I want to find the sine of 30, and this is just going to be like 1, and this is going to be like now minus root 3 or something, that's incorrect. And the reason for that is we want to know what's 90 plus 30. Well, what is 90 plus 30? That's 120, right? 120. And so if we basically had to move this triangle up 90 degrees, we would get something that looks like this. We would get something that looks like this. And what's this angle? Well, this angle will be 30 degrees, right? This is our 90, and this is our 30. 90 plus 30. But wait a sec. So the angle that we're going to be using to find out our answers here is actually the other one. It's actually 60. I hope this makes sense to you. I really hope it does, because this greatly confused me at first. So our triangle is actually going to look like this. Obviously, hypotenuse is still going to be the same, but now this length over here, for the purpose of trigonometry, remember when you use a Cartesian plane, you probably will just use a distance, but for trigonometry we kind of call this distance here now. Remember, that's going to be our 1 next to the 60. This is going to be minus 1 now. And this this is still a positive height, so this is root 3. So for me, the biggest mistake you can make here is to think that this is 30. It's not, it's 60. So how do we go about this? Well, now it's basically trying to find the sine, cos, and tan of this angle. So what is opposite over hypotenuse? That'll be our sine, root 3 over 2. And surprise, surprise, it's positive. Remember, cos, sine is positive in this quadrant. With cos, we have our adjacent over our hypotenuse, which is going to be minus a half. And with our tan, it's going to be opposite divided by adjacent. So that's going to be negative root 3 over 1. So why did I show you all of this? Can we write these things down in concrete terms? We actually can. And we do have some time, so let's do that. So let's see. The sine of 90 plus theta. For me, it's more important that you understand how to do this computation I've done now than that you memorize these, because there really are so many of these. It's more important that you're able to use the computations properly. Anyway, sine of 90 plus theta. Well, have a look at this. This is root 3 over 2. Well, this is root 3 over 2. So we've basically done a proof now. The sine of 90 over theta is the same as cos theta. Cos of 90 plus theta? Well, what's that? We've got negative a half. Wait a sec, that's a half. So that's minus sine theta. And the tan of 90 plus theta, well, this is a little bit interesting. This is negative root 3 over 1. The tan of 30 was 1 over root 3. So this is actually negative the inverse. What's the inverse of tan? Tan of theta is 1 on cotan, right? Theta, and well, cotan theta is 1 over tan theta. So let me remove this just for to make this look a little bit neat. This is going to be negative cotan theta. So I hope this makes sense to you. In the next video, I'll quickly show you how to do a 180 plus, but using the same methodology. You can do a 90 or a theta minus 90. You know, it's going to be triangles over here. You can do a minus 90. You can even do a minus 90 minus theta, which will be over here. So it's really important that you're comfortable, that you train yourself a little bit how to work around this cost diagram. Anyway, I'll see you in the next video.